Hope you're doing well. Welcome to your first lesson for grade 12 biology. We are going to be starting off with Unit 1, which deals with biochemistry. So by the end of this lesson, you will be able to explain the difference between intramolecular and intermolecular interactions, describe electronegativity, and the importance of functional groups. So what is biochemistry? It's the branch of science dealing with the properties of biological molecules and the chemical process that occurs within living organisms. Atoms, elements, and compounds. Hopefully these are all terms that you have heard of before. All matter is composed of elements which cannot be broken down into simpler substances. Matter also cannot be created or destroyed. There are 4 essential elements account for 99% of atoms that are found in a human body. So 99% of the atoms that make up you, who you are, is made up of 63% of hydrogen, 26% of oxygen, 9% of carbon, and 1% of nitrogen. There are also other essential elements that can be found in your body that make up the other 1%. So we have mineral elements that make up 0.07%, and then we have trace elements which make up less than 0.01%. And these trace elements means that it is such a low concentration that's found in the body, but it still plays an important role in some functions needed for your body. So the atom is the smallest particle of an element that maintains the property of the element. We have the atomic number, which is equal to the number of protons, which is also equal to the number of electrons. Our mass number is equal to the number of protons, so not proteins, sorry, this should be protons. So mass number is equal to the number of protons plus neutrons. So looking at the image up here kind of gives a good example of what our atomic number is. So if you guys remember correctly, atomic number is the number of protons and it is also the number of electrons. So this number tells us up here that carbon has 6 protons and 6 electrons. The atomic mass is simply the amount of protons and electrons that are found in the atom. So we know that there are 6 protons, so in order to find out how many electrons there are, you would simply take the atomic mass subtracted by the atomic number in order to find the amount of electrons, which would be, number of neutrons, which would be 6. Hopefully, again, this is not new for you guys. And down here, we also recognize and see, hopefully, a Lewis structure of a Lewis dot diagram structure of a carbon, and it's showing us 4 valence electrons. Remember that valence means that it's the outer shell that you would find in your atom. So this is telling us we have 4 valence electrons. It also shows us and tells us that carbon is able to make 4 bonds. So it wants to gain 4 electrons or lose 4 electrons. Remember, atoms like to have a full shell, whether it's able to gain or lose its electrons, whatever is easier for the atom to do, and basically what is available for this atom to either collect or get rid of its electrons. Also remember that our protons are positively charged and electrons are negatively charged. So if you are to lose electrons, then this means that your atom would become more positive. If you were to gain electrons, this means that your atom would become more negative. We have isotopes. Isotopes are atoms of the same element that have the same number of protons but a different number of neutrons. The atomic number remains the same, however the atomic mass will change. And this makes sense because if an isotope has different amount of neutrons, if you were to, the atomic mass is made up of neutrons and protons. So far this makes sense. At the bottom of the page here we can see some different examples of isotopes, specifically in carbon. So on our left hand side here we have a natural occurring carbon that's found abundantly all over the world. And then we have isotope variations of carbon, which is carbon-13 and carbon-14. So this carbon-13 here is the atomic mass, and basically it tells us that we have 7 neutrons, and same with carbon-14 over here. It's telling us that we have 8 neutrons that are present in this isotope. Some isotopes are unstable, which means that their nucleus decays. It breaks down by emitting radiation in the form of a subatomic particle or electromagnetic waves. Unstable isotopes are radioactive and they're referred to as radioisotopes. So that's what a radioisotope is. It's an unstable isotope that undergoes nuclear decay over time by emitting radiation. Carbon-14 is an example of a radioisotope. Radioisotopes decay in a predictable manner, which is called the half-life, or the time that it takes for 1/2 of a nuclide to decay over a period of time. So we do use these radioisotopes in ways of helping us in our medical fields or in science in a lot of different ways. One of the ways that we use radioisotopes is is a valuable diagnostic tool in medicine. So it helps us to diagnose diseases such as cancer. I'm going to play this video for you here, but you guys can also find the link in your PDF file as well.
A PET scan creates 3D images of the body. It does this by using radioactive tracers, which are usually administered to a patient through intravenous injection. The tracers are made up of carrier molecules that are tightly bonded to a radioactive atom called an isotope. The carrier molecule can interact with or bind to specific proteins or sugars in the body. The carrier molecule that will be used depends on what the doctor is looking for. If she suspects cancer or is monitoring a known cancer's growth, she may use FDG, a modified form of glucose, which gets absorbed by tissues. When tissues absorb a lot of glucose, it may indicate a cancerous tumor. The radiation from the tracers poses little danger to the patient since they quickly pass out of the body. The isotope produces small particles called positrons, which interact with surrounding electrons. This interaction results in the complete annihilation of both particles, releasing 2 photons that speed off in opposite directions. The detectors in the PET scanner measure these photons and use this information to create an image of the distribution of FDG in the body.
So they are find the link file.
How do we know how old something is? For people, we'd ask to see their birth certificate. For trees, we'd count the rings. But how do we know how old a fossil is? Fossils have their own internal clock. Scientists can read it by looking at the ratio of 2 different types of carbon atoms. Of course, every living thing is made of carbon. Plants grab carbon dioxide from the atmosphere and use it to form complex organic molecules. Animals get their carbon by eating these plants. But there's more than one form of carbon. Most carbon atoms have 6 protons and 6 neutrons. We call this carbon-12. High up in the atmosphere, sometimes cosmic rays hit nitrogen atoms. This creates carbon with 6 protons and 8 neutrons. We call this carbon-14. Carbon-12 and carbon-14 behave alike, but carbon-14 has one unique and important attribute. It's unstable. So once an animal dies, the carbon-14 in its body will start to go away. Every 5,730 years on average, about half of the carbon-14 atoms will decay into nitrogen. This is its half-life. After one half-life, the animal will have about half the amount of carbon-14 it started with. After another half-life, it will have about a quarter. And after another half-life, it will have about an eighth. By contrast, the amount of carbon-12 it has in its body will stay the same. By measuring the ratio of carbon-14 to carbon-12, we can measure how many thousands of years have passed since the animal died. Carbon dating works for fossils up to about 60,000 years old. For older fossils, scientists use unstable elements that have much longer half-lives. For Scientific American's Instant Egghead, I'm Michael Moyer.
Involved in oxygen holds the bond in that ionic bond in place. Ionic, you have them being bonded here close together, each other that between ionic bond intramolar force. Covalent is when you have more non-metals that interact with each other, how intramolar an ionic atom giving another atom and positive negative through that It's a chemical of carbon. This is bonded to the, so this is in the back of this slide here. It's being bonded, not a measured element with positive charge. So that stands for En, electrons, electronegative bound in the negative charge. This is what simple or covalent atom particles. Remember that this delta, so you're having 0.0 delta En atoms. The previous more compared to so in there are shared atoms because activity are hydrogen, so negative 4 and for 3 point. So find the what take or you're going to enter bond. Water molecule is negatively. I'm going to pause the video here and I want you to look up the different electronegativity for each of the atoms, and I want you to tell me what type of bond is taking place. So the intramolecular bond that's taking place between these two atoms here, and I want you to tell me if it's polar, nonpolar, or ionic bond. So please pause the video and you can try that out. Okay, so now that you have time to try it out, I'm going to give you the answers. So for A, it is an ionic bond. For B, it is a nonpolar covalent bond. For C, it is a nonpolar covalent bond. And for polar of polar molecular, these mirroring part means based on this or based on it is and just bond an unequal of charge means maybe contain carbon. This is H foot's pause here, and our water is a between a molecule because of the it makes a place this entire